The construction of a new navigation dam near Braddock, Pennsylvania, will initiate the final phase of a program to modernize the locks and dams on the Monongahela River. The existing Dam 2, a nearly 100-year-old fixed crest structure, will be replaced with a new, more operable gated dam, allowing the Army Corps of Engineers in Pittsburgh to replace old and inadequate locks at Charleroi and completely eliminate locks in Dam 3. The new Braddock Dam will be built using innovative in-the-wet construction techniques to achieve cost and time savings and improve quality. This video presents the sequence and methods of construction, while also detailing key elements of the new dam. The dam will be constructed utilizing two large prefabricated concrete segments that will be floated into place above and set down upon a pre-constructed foundation system. The foundation system will consist of sheet pile cutoff walls and large diameter drilled shafts installed in a pre-excavated area upstream of the existing dam. Once the segments are placed in the wet to form the base of the new dam, the balance of the dam will be constructed above the water by conventional methods. The government-furnished location for the disposal of dredged materials from the new dam site and approach channel is located on the left bank approximately 2 miles upriver from the new dam. The offloading facility will also be used as the outfitting site for the two float-in dam segments on their trip from the fabrication site to the new dam location. After pre-excavation, steel sheet piling will be installed to provide both upstream and downstream cutoff walls and to serve as retaining walls for various stages of work on the dam. The upstream cutoff wall will be installed first. Using a barge-mounted pile driver, steel sheets approximately 25 feet in length will be installed in 35 feet of water between H-piles, with pre-installed interlocks at a 19-foot spacing. Followers will be utilized to drive the sheets to the required top elevation without underwater cutting. The downstream cutoff wall will be composed of a structural system of 24-inch diameter pipe piles and sheet piles. The downstream cutoff wall will extend from a connection with the modified lock river wall to the end of the float-in dam segments and then turn upstream along the left end of the dam until it connects to the upstream cutoff wall. The pipe piles will be driven to rock, from which point a reinforced concrete rock socket will be extended 6 feet into the rock. The pipe piles will also be strategically positioned to support the downstream edge of the tail race structure. Sheet piles will be connected to the pipe piles by a special interlock section that is welded to each side of the pipe pile prior to driving. Then the dam foundation will be constructed. This system is comprised of a drilled shaft foundation system for the float-in dam segments and an H-pile foundation system for the tail race. For the dam foundation system, two types of drilled shafts will be installed. Set-down drilled shafts for support of the dead weight of the float-in dam segments at set-down, and foundation drilled shafts for support of the completed dam. 6 set-down drilled shafts will be provided for each segment. 77 foundation drilled shafts will be provided beneath the dam piers and gate sills. Drilled shafts will be precisely located using a pile-anchored guide template. The float-in portion of the dam will be approximately 600 feet in length and 104 feet 6 inches wide. This total length will be divided into two floating segments. Float-in segment 1 at 333 feet and float-in segment 2 at 265 feet. The float-in segments will comprise the gate sills, a portion of the stilling basin, and the pier bases up to elevation 726. Segment 1 will include the fixed weir bay, the water quality bay, and one of the standard gate bays, while Segment 2 will include 2 standard gate bays. The two float-in dam segments will be constructed at an off-site location, while the dam and tail race foundation systems are being completed at the project site. Segments will be transported from the off-site assembly location to the project site for additional outfitting prior to set-down. Float-in segments will be constructed with precast wall and diaphragm panels and cast-in-place bottom and top slabs. There are 3 basic options for assembly and launch of the float-in segments. One feasible method is to use a conventional dry dock or graving dock. A second feasible method is to use a 2-level casting basin. When the precast dam segment is ready for launch, the upper and lower basins are flooded to a common water level, and the segment is floated over the lower basin. The water level in the lower basin is then returned to the outside river elevation, the exit dike is removed, and the segment is towed out of the casting facility. A third feasible method of assembly and launch for the segments is to use a large offshore-type deck barge, roughly 360 feet by 105 feet, moored at a prepared construction site along the riverbank. Following assembly, downstream transport bulkheads will be installed and the segment then launched. Each segment would then be towed to the outfitting site upstream of the immediate project site. Once the segment arrives at the outfitting site, it will be moored to the outfitting pier. The piers of each delivered segment will be extended approximately 21 feet. The segments will be completed and readied for set-down at the outfitting pier. Once outfitting is completed, the segment will be lashed to the primary tow to begin its 2-mile trip downriver to the new dam site. Segment 1 will first be maneuvered downriver by the primary tow and guided by a snubbing tow. After positioning close to the set-down site, mooring lines will be connected. The segment will then be rotated and winched downstream and positioned directly over the top of the 2 horn guides located on the face of the river wall. After each outfitted segment is maneuvered into position, it will be ballasted onto its 6 set-down drilled shafts. By adding water to the gate bays and using the horn guides, mooring lines, and land-based survey control for guidance, each segment will be accurately lowered into position. Underbase grouting may begin once the segment has been aligned and leveled. After underbase grouting is completed, the dam segment will be locked onto the foundation drilled shafts by pumping a sand-cement grout into the hollow recesses surrounding the shear pin and tension anchor assemblies. And the 28 ballast tanks will be filled using the 2-stage TREMI and in the dry operation. Following completion of the underbase grouting and concrete infill operations, the dam's tail race will be constructed in the wet. The tail race will be built utilizing precast panels that are 30 feet 6 inches wide by 20 feet long by 15 inches thick. These panels will be supported on the upstream side by the float-in dam segments and on the downstream side by the row of previously installed pipe piles, which are integral with the downstream cutoff wall. The area below the tail race panels will be filled with TREMI concrete to create a mass concrete tail race section supported by the previously installed H-pile foundation system. The upper portion of the dam piers between elevation 726 and elevation 765 will be placed in the dry after the float-in dam segments have been set down and filled with concrete. This portion of the dam piers will be completed with a combination of precast concrete and conventional cast-in-place concrete. The downstream third of the pier will be conventionally formed cast-in-place concrete to facilitate the installation of the trunnion girder and cylinder girder anchorages. A pier building will be erected on top of each pier above elevation 765. Trunnion girders will be attached to the downstream face of each of the 5 piers, thus providing support for the 4 tainter gates. Following completion of the installation of the first tainter gate, the baffle blocks will be installed. The bay will be flooded and the bulkhead structures will be moved to another bay. All 3 standard gates and the 1 shorter and lighter water quality gate will be installed in a similar manner. A reinforced concrete and steel footbridge structure will be constructed to provide pedestrian access across the lock chambers and to the dam piers. Following completion of the dam piers and installation of the tainter gates, the left closure weir will be constructed. This structure will connect the left end of the new dam to the existing left abutment wall, providing a fixed weir crest at elevation 725. The closure weir will be comprised of 2 52-foot diameter sheet pile cells driven down to the top of rock. After the existing dam has been breached, the lowered water level over the intervening space will allow for the construction of a variable thickness reinforced cast-in-place concrete cap to complete the weir crest. The alluvial overburden will be completely excavated to the top of the rock. Next, heavy stone will be placed in the excavated area up to elevation 686.7 to provide a downstream scour protection for the dam, closure weir, and left abutment wall. The in-the-wet construction of the new gated dam at Braddock is expected to save time and money when compared to traditional cofferdam construction. With extensive use of high-quality precasting operations, the finished dam will be more durable and have an extended useful life. This pioneering effort by the Pittsburgh District is expected to lead the Corps of Engineers into the next century of innovative construction technology.